pleasure to be here today speaking with you about this, this new topic here that we're going to be talking about, which is MASH. So my outline is pretty simple. It goes along with the presentation title, What, When, and Why. So let's just jump right in. What is MASH? Well, basically MASH stands for Manual for Assessing Safety Hardware. It is a document that provides uniform guidance for testing roadside safety features. So we're talking about features such as guardrails and other types of barriers and crash cushions and so forth. So when we say guidance, what does it provide? Well, it specifies the test matrices for these different categories of hardware. And it uniquely specifies a vehicle type, an impact speed, an impact angle, and even the impact location on a given device, and provides us evaluation criteria to objectively evaluate the impact performance of those systems before they're ever installed on the highway. MASH is the latest in a series of guidelines for testing roadside safety hardware. You can see a bit of that evolution on this slide. We were starting with, in 1962, Highway Research Circular 482. That was a one-page document. If you go down to 1993 with NCHRP Report 350, which perhaps some of you are familiar with, that now had become a 132-page report. So MASH superseded Report 350 in 2009 when it was published as an AASHTO document. So as I mentioned, MASH addresses all types of roadside safety hardware. You see some examples of that here, from guardrail systems, breakaway sign supports, bridge rails, and crash attenuators. There is scheduled for release in 2016 an update to this document. And I would say that probably the most significant change in the 2016 version is the inclusion of some test matrices for wire rope median barriers, and specifically some guidance on how to test and evaluate those systems in a median ditch, because we recognize that almost exclusively they're being placed in ditches, and most of our testing of barrier systems is conducted on flat level ground. So what about the when? We know now we're dealing with MASH. When is this going to become relevant, and when is this going to apply? Well, the AASHTO Technical Committee on Roadside Safety, along with the Federal Highway Administration, have adopted an implementation plan for this document. Basically, it's saying that after December 31st, 2019, if you have a project or a contract let on the National Highway System, that you should only be using safety hardware that complies with this MASH criteria. There is more specific guidance in the adopted implementation plan. There are staged implementation dates by categories of hardware. I'm not going to go through this because our next speaker, Mr. Dick Albin from Federal Highway Administration, is going to go over this in more detail. So now we're to the why. And why do we want to adopt MASH? Why is MASH important to us? Why should we take all this effort to evaluate our hardware to this document and go through this implementation process? Well, essentially, this is a document that helps us with roadside safety. And in my opinion, the status quo is never acceptable. We heard from Dr. Rosekind at lunch that we continue to have a very sizable roadway safety problem, and with still over 32,000 deaths. So we need to continue to look for ways to improve, ways to enhance our safety hardware, ways to have some new significant advancements. And that's what MASH represents to us. It's basically the next step in that advancement or evolution of roadside safety testing and evaluation. It addresses a number of changes that we've seen in the vehicle fleet to keep it more relevant. It reflects various advancements in knowledge and technology that continue to occur. And ultimately, what we're looking at is that through the implementation and adoption of this document, we'll have improved roadside safety hardware that will in turn enhance safety for our motorists. So our overall objective is to help reduce those injuries and fatalities that result from roadway departure crashes, and roadside safety hardware is one of the key elements in that equation. So what are some of those key changes that we're talking about that are going to help us and influence this safety equation? Well, in regard to the test vehicles, there have been some significant changes that I'll just address quickly. The small design test vehicle, you see that the weight increased from 1,800 pounds to 2,400 pounds. In some people's eyes, they would say, well, is that really an advancement in safety? The issue there was, believe it or not, you could not find vehicles of that weight any longer. So that 2,425 pound vehicle is actually a 98th percentile vehicle, meaning that only 2% of the vehicle sales are vehicles that weigh less than that amount. So this was something that we were doing to be able to identify and obtain test vehicles and keep that relevant to the fleet. Now, more significant in terms of benefits that I think we'll realize from the MASH implementation is the change in the large design test vehicle. There was a pickup truck test vehicle under Report 350, which was the predecessor to MASH. And that pickup truck vehicle was retained in MASH, but it changed in terms of its style and its weight. So before, where it was a 3/4 ton 2-door pickup, now it's a 1/2 ton 4-door pickup. So that was intended to better represent a lot of the sport utility vehicles that we have in our fleet. The weight increased from 4,400 pounds roughly to 5,000 pounds. And again, that was a reflection of the changes in the vehicle fleet and the increases in weight that we see in those vehicles. And the minimum CG height was specified and is in fact higher than what we were previously testing with. So the bottom line, the large design passenger vehicle increased in weight and it increased in height. And there's an example of that right there for you, where you see the Report 350 pickup truck on the left and what we're typically testing with under MASH on the right. So what are some of the other changes? There are some other changes that are significant in regard to the test matrices. Previously, the small car impact angle, when we were evaluating a barrier in terms of impact performance, was 20 degrees, and that's been increased to 25 degrees. And that's a reflection of the crash data that we've seen out in the field. So there was a review and analysis of real-world crash data, and we're trying to adopt test matrices and impact conditions that reflect that real-world crash data. One thing that I did not mention was the single unit truck. That's the SUT. That's going to come up a little later in the presentation. That's a little larger design vehicle when we start going to some of the commercial trucks. And that changed not only in terms of the impact speed increasing, but if you see down there below, see, there we go, the weight of that vehicle, that truck actually increased under MASH as well. So the bottom line is that the impact severity, the amount of energy that we're having to manage, has increased substantially depending on what test level or test designation you're looking at. There's some other changes in MASH too that will be relevant to us moving forward. Briefly mention some of these. For instance, the variable message signs and aero board trailers. There was they were not addressed at all under Report 350. They've been added in. Some of the test criteria for the terminals has been modified to include a broader range of impact conditions that we see in the real world, particularly some shallow angles here on our terminal systems. On breakaway supports and breakaway hardware, we were previously only testing with the small car, and we've added the pickup truck into the matrix, and I'll show you why that was relevant in just a moment in an example as well. So you can see that there's a variety of changes that have been incorporated into this document. But what does that overall mean to the benefits that we'll derive from this document, the safety improvements that we'll realize? Well, I thought I would do that through 3 illustrative examples here. So the first example we're going to talk about is what I would call a standard W-beam guardrail under MASH test level 3 conditions. That's the basic test level for high-speed roadways. The second example will be a test level 4 barrier where we're starting to look at that single unit truck. So this is a little higher containment barrier system that deals with some commercial trucks. And then finally, I was going to talk a little bit about breakaway sign supports, the inclusion of the pickup truck and the relevance of that to some of our breakaway testing, as well as some other evaluation criteria that's related. So this first example, what I call here a G4-2W W-beam guardrail system. So what is a G4-2W? Basically, that's a secret code that only researchers that have been in the industry for 30 years can interpret. So, but seriously, what this is probably your most conventional type of guardrail system that you would see used in any state. You have what is referred to as that W-beam guardrail. It's just a metal rail supported on some, in this case, some timber posts. There's also steel post alternatives. And so this system right here, as you see it depicted, successfully passed NCHRP Report 350 Test Level 3 with that previous pickup truck that I mentioned to you. However, as you recall, under MASH, that pickup truck now has become taller and heavier. So we go through a process of reevaluating some of our existing hardware to this latest standard and trying to see if it's compatible or if we need to make some improvements. So let's see what happened with our standard W-beam guardrail under the MASH test conditions. So that's not what we like to see happen. Obviously, that is a failure. You'll see another view of this here. So this larger, heavier pickup truck actually exceeded the capacity of that guardrail system as it was configured. The rail ruptured. It permitted the pickup truck to penetrate and go through the rail system. So it did not meet the MASH criteria. So what we're hoping to do under MASH is when we see these types of deficiencies, we can redesign the guardrail system to improve its performance. And then we're going to realize benefits from that out in the real world. So for instance, we're now accommodating a broader range of vehicles out there, some heavier, taller vehicles. And you saw an example here of this improved guardrail system or enhanced guardrail system. So this new guardrail system was raised in height to 31 inches, and the rail splices were offset between posts, which effectively increases its strength. So this change was made without any change in cost to the actual guardrail system. The posts are the same length, the system's just been raised up, and the rails have been offset. And so you're able to achieve a significant increase and change in performance, meet the latest MASH criteria without really, in this case, any appreciable change in cost. So that's a win for everybody. The next example is a test level 4 barrier. So I mentioned test level 3 was our basic test level for high-speed roadways. That just deals with passenger vehicles. Now with test level 4, you start introducing some of the larger trucks. And so let's talk about that. So when we're talking about test level 4 and the single unit truck, we see that the impact speed has increased from 50 miles an hour to 56 miles per hour. The weight of that single unit truck has increased, and that results in an overall increase in impact severity or lateral energy going into the barrier of 56%. So if we look at a system that you see on the left-hand side, that is one of the most common types of bridge rails and median barriers that you would find in a state. In this case, it's a 32-inch New Jersey safety-shaped concrete barrier. This successfully met NCHRP Report 350 Test Level 4. So this test is now evaluating it under MASH. So this is MASH Test 4-12. And you can see that it's rolling over that barrier. That truck is no longer being contained and redirected, it's rolling over the barrier. So once again, we have to look and we have to say, well, what do we need to do to make improvements to that? There is some research that's been done. That research was conducted at Texas A&M Transportation Institute, trying to basically evaluate what should be the new minimum rail height for MASH TL4 barriers, given that 32 inches is no longer acceptable. And also, given that the impact severity has increased, what should that design impact load be? Well, you can see here that the research indicated that 36 inches should be the new minimum barrier height for TL4 impact conditions, and that design impact load that was previously 54,000 pounds under Report 350 has increased to 68,000 pounds for a 36-inch barrier, and in fact can go up from there for taller barriers due to the way that the truck interacts with the barrier system. So if we're now looking at this new barrier system, here's an example. This is a 36-inch tall now, single slope concrete barrier being tested under that same impact condition that you just saw for the 32-inch barrier. And you'll see here better impact performance. The vehicle stays upright, it's contained and redirected by the barrier system, and it meets all of the MASH criteria. And the final example, which deals with sign supports. Here's an example of a sign support system that was tested under NCHRP Report 350. This is a slip-based sign, albeit these sign panels are really a little smaller than were initially intended to be used on slip bases, and that's why you're seeing that secondary roof contact there. So you can see as that support releases as designed, it rotates around, there is some secondary roof contact. It met NCHRP Report 350 because Report 350 had more forgiving roof crush criteria. Now under MASH, that 5.6 inches of roof crush that we saw in that particular test is no longer acceptable. MASH limits that to 4 inches. And so that system would not currently pass MASH. So what do we do about that? Well, we have to properly use these systems. So it's not always a matter of changing the design, but maybe properly using it. So there was a TxDOT research study, 6363, where the minimum sign area for slip bases was evaluated. And so you can see here in this results table that if you're using a slip base, you know, that we were recommending that you have a minimum of 14 square feet. It was much less than that in that previous test that I showed you. So we did confirm this or verify it with some full-scale crash tests. So this is the same slip base system, but with a little bit larger sign. You do see that because of the contact of that sign on the rear edge of the roof structure, it did break out the rear window, but there is no penetration into the vehicle. And in this case, it resulted in only 2.5 inches of roof crush, and at a point that was much further back on the vehicle. As you increase the sign area above that minimum level, then you're going to get to a point where you wouldn't even have any secondary contact at all. And then this is the final illustration here, or example, related to sign support systems. This is a temporary sign support system. When we're testing a temporary sign support system, we test it both at 0 degrees and at 90 degrees, because many times these temporary support systems, which are used in work zones, they're rotated out of view when they're not in use, so they can be impacted at 90 degrees. So what was difficult to see in that high-speed video there was that sign panel actually tomahawked the top of the roof of that truck. Now, we had not previously been testing with pickup trucks. This would have passed the small car. It would have passed right over the top of the small passenger car without incident. But in this case, it actually cut through the roof, and you can see Dusty, who's going to be presenting later, sitting in here, and that's not a good situation. You don't want that to happen. So once again, that would not meet MASH. That's penetration of the occupant compartment. So we can come up with design alternatives for that. This is a similar aluminum sign panel. What we had is we kind of had some fuse plates below the sign that were able to bend and activate. And you can see that although there's some secondary contact on the roof, there's no penetration and virtually no deformation of the roof structure either, in 2 different design options that we came up with there. So that met the MASH criteria. So that was my presentation. I hope that I was able to illustrate some of the differences, the changes, and why those are going to benefit us moving forward with some improved safety hardware.